Hi guys, Igor again. Today we talk about table partitioning. So let's go. What it is? It's basically one of the techniques to optimize our queries among indexes and sharding. And it is splitting your database table to multiple subtables, partitions, so that we can reduce the search space and make our queries faster. So basically having a table like that, account, we will divide it in a few tables like account 1, account 0, account 1, account 2, and so forth. And for some queries we can search items in only one of those tables, which obviously is smaller. So to do that, we need to have certain partition strategy, and particularly in Postgres, Postgres supports declarative partitioning, where it handles it for you more or less automatically, meaning that we will just refer to account table, and underneath Postgres will figure out which partition subtable it should query. So in our example, we will use country code as a partition key and list as a strategy. It means that for each row that has country code with the value 0, it will go, rows like that will go to account 0 table. For country code with value 1 to account 1, country code value 2 to account 2, and so forth. But that's only one of the partition strategies. We'll use it in our example, but just to give you some context, we also have range strategy, where you can say that for country codes from 0 to 10, for example, we want to insert these rows to account 0 table, from country codes from 10 to 20 to account 1, 20 to 30 to account 2, and so forth. And also we have hash strategy. You can say where we take hash value of our partition key, which in our case is country code. We modulo this by a certain number, let's say 3, and with the remainder 0 for that operation. For these rows, we insert them in account 0. For rows where this operation equals to 1 to account 1, and for others to account 2. And what else? Also worth noting is that primary keys and unique constraints, if you partition your table, they need to have a partition key, which is country code in our example, as a part of this key, or unique constraint, and you can't really have unique constraint enforced across all of your tables. So for example, ID, it will be only unique in each partition, so account 0, account 1, account 2, and so forth. That's one of the limitations. And we can create index as on normal tables, and we'll show this in an example, but it will be recreated for each partition. So advantage is that it will be smaller. And to compare queries performance, I also have created account not partitioned table, which is identical to this one, but it is not partitioned, and we have the same index. Okay, and what else do we have? So we have build and run script that will build Postgres database during these examples. We have a schema, some queries, and we also have some Java code to help us with the examples. So, and the partitioning package, we have account record, which just models account table. We have account repository, where I use Joku to talk with the database to prepare partitions. and this is how you create partition basically. So you create table. I use if not exist clause to make it idempotent, and here we name it as we want. I name it account dash country code, and the country code is for us just an integer from 0 to 20, I believe. You say partition of name of the table, 4 values in, and it's the same as in the name. So account 0 will be for values 0. And we also have create method to create accounts and insert them to account table and account not partition table. And we have partitioning up, which generates some random data or executes queries. And in prepare data specifically, we can insert 1 million records and some batches before they create partitions. We are doing this in parallel. I have run it in advance so that we have more data to work on, because it does take some time to run all of these inserts. So if we go to partitioning and run bash build run and start our Docker container, and let's see what do we have. We have Postgres partitioning, doing docker exec P.S.Sorry where we'll run all our examples. We are in the database, and let's check its size. So in the Postgres database we have almost 9 gigabytes of data, and if we count all of the accounts, yeah, so I have prepared 21 million rows, as you can see, which is quite a lot, but to make performance differences more visible. And we have similar amount in account not partition table. But to make sure that it works, let's run this prepare data script, but maybe with like, I don't know, 100,000 rows. Let's run it. Okay, we have connected to a database, and we are inserting something, so let's wait a while. 34,000 records. We are waiting. Yeah, and basically it took 19 seconds to insert 100,000 records. Let's get back with that. And let's run our queries, guys. So first, let's see what do we have. We have account table, and you can see that this partitioned table. Maybe let's do this. Yeah, we can see size in bytes. So we have 20 partitions, as I have created here according to the country codes. We have 0 to 19. And as you can see, I've inserted to it randomly, so the partitions are more or less of the same size, which is quite small. Yeah, 111 megabytes, because if we do that, let's turn on timing. If we do select country code, count from account, group by country code to see how many, records we have in each partition. Yeah, so it's almost 11 million, but you can see that it's almost the same in each partition. Okay, and account not partitioned, it has more or less the same size, but in just one table because it is not partitioned. And as you can also see, we don't need to specify account 0 here. Postgres is handling that for us, so we can also do select count from account where country code equals 0, for example. And if we do explain analyze, you can see that Postgres has figured out that it should search only in account 0 table, which is partition of account. And here you can see also the specification of partitions. So that's quite nice. And what else? Also, when we were preparing the data, creating it, I just inserted into account table, so I also didn't need to specify to which partition I wanted to insert my data. Postgres handles that automatically by its declarative partitioning feature, which is quite handy. Right, so let's run some queries, guys. So, for example, we have primary key on both tables, but with the partitioned one, we have country code first. So let's just run. Let's just select something from account, which is partitioned. We have some IDs, and if you do that, so select from account where ID equals something. It's quite slow, as you can see, because if we do explain analyze, as you can see, Postgres decided to do parallel sequence scan on each partition, and we have 20 partitions, and interestingly enough, it didn't use the index, so we can turn off the sequence scan to see whether it will be faster or not. So let's do that. Okay. That's actually super slow. Yeah. Let's do this maybe without explain analyze. Yeah, and it did take longer. Right now I think it's faster. So let's turn it on again. Yeah, but it is quite slow, and if we do and country code, let's say in 2 partitions. Yeah, it is significantly faster, as you can see. And if we do explain analyze, yeah, it used index scan or 2 tables basically. And if you compare it to account not partitioned, it's fast, because we really here where we don't have partitions on account not partitioned, we just have index scan, as you can see, because of the index, which is only on primary key, which is only on ID field. And if we do, guys, I don't know, let's go back to also with sorting, for example. So from account, let's order it by ID, limit to 10. Yeah, it's quite slow, as you can see. And again, because explain analyze, yeah, so We're doing a lot here, so we are doing parallel sequence scan on each partition. That's why it takes so long. And again, if we limit it to only one partition, let's say 0, yeah, it's quite fast because of the index scan, and probably even to, I don't know, let's say a few partitions, maybe 3. Yeah, so it decided to do parallel sequence scan, but still, because we have 3 partitions, it takes like 200 milliseconds. Let's see, for 2. Yeah, for 2 like 100 something, and with only 1, yeah, it is blazingly fast basically. And obviously for account not partitioned, if we do this, it will be fast because we have an index. Okay, and for both tables we have also index on a name. So if we do select from account where name equals n, this, let's say, it is quite fast. This is partition table. Let's do explain analyze out of curiosity. And here we are doing index scan. It's quite fast, but as you can see, we are doing this on each partition. So if you have hundreds of partitions, it probably still will be slow. We have only 20, so it's quite fast. And for account not partitioned, yeah, it's a little faster. And also with explain analyze, we're doing this only on the index of one table. And if we go back to the partitioned one, we can have similar effect if we know that we need to select from certain partition, which is 0. Yeah, and it's basically of the same speed as one which is not partitioned. And yeah, we have index scan. So as you can imagine, the most desired scenario for partitioning is if most of your queries they have partitioned key in the where clause, because then you can really optimize. But usually you should just start with the indexes, and if you can't, you can partition your table, and if that's not enough, you can always do database sharding, but that's more complicated, obviously. Okay, so maybe let's run one example where we also had the field without index, which is description. So if we do select from account, which is partitioned, where description, I know something, it takes like that. And also one caveat, guys, we are doing this on database that it's not under any load. So as you can see, CPU is 0, and let's maybe check something. So it takes like 1 second, something, should be similar for not partitioned. Oh, a little longer. Interesting. But it shouldn't. Yeah, but still for account not partitioned, let's explain Analyze. Parallel sequence scan. And should be the same for partitioned one. Yeah, parallel sequence scan, but on the all partitions. Okay, but anyways, 1 second. Database is not loaded, let's say. So let's run execute queries function in my script. And here we basically run some queries. Some of them can use indexes, some of them cannot. And we load the database basically. So as you can see, CPU is like 40%. We influence the query. Yeah, it is. So it is a little, does take a little more time. And if we do something even more taxing, like we can have more queries issued by modifying that. Let's see. Yeah, so more load. Let's change something. Yeah, so queries are a little slower, as you can see, around 2 seconds. Yeah, and actually for the query of indexes, it is still fast. Okay, so let's turn it off. We're back to no load basically. And what we can do, so one of other side advantages, depending on your scenario for partitioning, is that even though we don't have an index here, and it takes 1 second because of that, if you know from which partition you are searching, you can add it to your workflows. So we do country code. Let's search actually in 3 partitions. So without that, it took around 1 second. You can see it is significantly faster because we still do sequence scan, but only on 3 partitions instead of all 20. So if you have data more or less equally distributed, it will be if in the example that we have 20 partitions, we can reduce it to 2, our search clause, our select clause. It will be like 10 times faster because we are searching only in 2 of the 20. And if you reduce it to 1, we basically have 5% of the initial time, more or less, obviously. And as you can see, it is more or less true. So if you search in 1 partition, I don't know. In 10 we have this. It takes like less than 100 milliseconds, close to 50 actually. Sometimes we have, and without it, it takes 1 second or more. Yeah, and if we take, I don't know, let's say 5. It's proportionally slower. Same if we do, I don't know, country code, see more than 10, which is half of our partitions. and it takes like half of the seconds. And at each step, reducing it will take less. One more thing that I forget, I think, is to compare the size of the indexes. So let me check out my queries. We have something here. So interestingly enough, if we go to primary key, this is the primary key size of not partitioned table. As you can see, it is close to 1 gigabyte. And if we run this on count, shouldn't exist, or it is 0 because it is partitioned table, so we don't have anything here. We need to go to each partition because index are defined for each partition, not for the table actually. And you can see they are all smaller, so it is also advantage that the index scans, they will be faster because of the reduced size. And I think we have also name. Name. You can see 64 megabytes. And for account, not account, but not partitioned, it is like name. Yeah, it is over 1 gigabyte, so keep that also in mind. Okay guys, so I think that's basically it. We learned how to partition the table, we know how to shard it from my previous video. We also played around with some with indexes and with some queries. So I hope it was informative, and I see you next time. See ya!